So assalamu alaikum guys. So let's continue till where we have left in the wireless charging for EVs. So till now what we have done is we have designed our wireless charging coil in the ANSYS, and we got the inductance of both the coil, that is self inductance, which is L1 L2, and the mutual inductance, and this is the coupling coefficient of the coil, and this is the internal resistance of the coil. And we have also seen that how magnetic field is generated by these coils when they are excited through a certain amount of current with operating frequency of 85 kilohertz. Now what the next step? So the next step is, so this is the general block diagram of wireless power transmission. So we have done with these coils, but now we have to design these blocks in order to get the output required power. Okay, so once recall the working of wireless power transmission. So the input of our system can be AC or DC. It highly depends on the user, on manufacturer. If it is AC, then there will be a rectifier here in order to convert that AC into DC. The AC is fed to high frequency converter. So the main work of high frequency inverter is to convert the amount of DC fed to it into a high frequency alternating current so that it can be fed to this coil. Okay, so then what is the frequency of this inverter? Its frequency is what we have specified in the ANSYS, that is 85 kilohertz. So this inverter will convert the DC current into alternating current, which is at 85 kilohertz. Okay, so then the alternating current, which is at 85 kilohertz, is fed to this primary compensation. So the duty of this compensation circuit, it has two duties. One is to block the unnecessary harmonics, unnecessary what we say is unnecessary signals, and it passes only the signals which are required for us, which are required for us. It will block the unnecessary signals like noise signals, etc. And the other work of this compensation circuit is to match the resonance condition between the transmitter and the receiver. Okay, so what is the resonance condition? So resonance condition is a condition at which both the circuits which are in resonance condition will work at a minimum resistance so that maximum power can be transferred between them. Like when the circuits are in the resonance condition, they will have a minimum resistance so that more amount of power will be transferred through these coils without any obstruction of resistance. Okay, this is what these both compensation are trying to do. Like they are just trying to maintain a resonance condition between these two sockets, and that transmitter and the receiver. Transmitter is embedded into the ground and the receiver is attached to the bottom of the car. Okay, then again here the current will be AC in the form of AC. Then you have to convert it again to DC, because if you fed the car with AC current, then there is a high chance that there will be a delay in the charging. So nobody wants to waste their time in charging their vehicles. They want as soon as possible their vehicle should be charged. Like what is a case in the gasoline, like in seconds your tank will be full. Minimum to minimum in minutes your gasoline tank will be full. So in order to make the charging process fast, we are converting our AC current into DC using these rectifier. Okay, then at last a filter capacitor will be present here, which will filter the harmonics which are undesired to us, and at last the power will be delivered to the load. Okay, So now we are done with these coils. Now we are going to design these circuits in the LT Spice. Okay, so let me just open the new file. Okay, so from here you will choose the select file and then go to new schematic. Okay, this is how the window will look once you select the new schematic. So now there is no components here, so now we have to place the components from the software. So here is a diode. Here these are the regular components which will use more when compared to other, so they are placed here. See, here are the capacitor, here is the inductor, here is the diode, and here are the components. Okay, so let's start with voltage source. Okay, so here's a voltage source. Place it anywhere and press escape to escape from this source. Okay, now what we are left with. Okay, one thing I forgot to tell you, that these compensation circuits are of 5 type, that is series, parallel series, series parallel, hybrid. So how we are defining this series, parallel, series parallel, hybrid? Then it highly depend on how you are placing your capacitors in the circuit. So this is the circuit of series compensation. Here you have placed these two capacitor in order to match the resonance frequency of these two circuits, and here you have placed the capacitor in the series in the transmitter and series capacitor in the receiver. So this circuit is termed as series compensation topology. Okay, in case of parallel, both the capacitors at the transmitter side and at the receiver side will be in parallel. When you talk about series parallel, then here will be in series and here will be in parallel. And then when you talk about parallel series, then here in the transmitter it will be in parallel and the receiver it will be in series. But now in our case we are going with series. Okay, so this is how our circuit will going to look. Okay, wait a minute. Yeah, this is how our circuit is going to look. Let's draw this. So here is the voltage. First we will add the voltage source. Okay, then it is the capacitor which is in series. So take the capacitor. So in order to rotate it, press it Control with R. Here how you can rotate the component in LT Spice. Place it here for the transmitter side and simultaneously press it here for the receiver side. Okay, now to escape from it, press escape. Okay, now then how we are exporting the values which we get in the LT Spice, like this inductance of the coil and the coupling coefficient. So these are the two quantities which are required in order to design the system. Okay, so yeah, exporting these self inductance in the form of inductor here in the LT Spice. So from here you can take the inductor, place it here, then press Ctrl R, second place it here. Okay, now we are done with these 2, 1, 2, 3, 4, 5 components. Now let's look at the receiver side. At the receiver you will find the rectifier in order to change the AC quantity into DC.